Thank you, Edward, for the invitation and give me the opportunity to talk with the industry. So I'm a data scientist in the applied research group, and today I'm going to talk about machine learning for cybersecurity. My talk is in the second series of CEADAR seminars, and you see other talk in the series on the screen. For my talk today, I'm going first to walk you through the modern cyber threat landscape, so to provide you some terminology in cybersecurity. Then I talk about machine learning for cybersecurity, how machine learning is applied in cybersecurity. Then talk a bit about CEADAR research in machine learning for cybersecurity. So first, what is cybersecurity? Cybersecurity is the practice of protecting computer systems and network from cyber attacks. These cyber attacks are carried out by cyber threat actors to access, to change, destroy sensitive information in a computer system of a business, to extort money from user or to interrupt normal business process. So as the book, The Art of War of a Strategist, Sun Tzu, he say, knowing your enemy and knowing yourself, and you win multiple battles. So this part is try to understand how the cyber threat carry out an attack against a victim system. So the guy from the Lockheed Martin company derive a term called cyber kill chain, which follows the term from Army, and it lists the steps that a cyber threat actor follow to attack a computer system. So it includes like seven stages. So the first one, reconnaissance. The threat actor would gather the email address and information about the victim computer system. Second stage, weaponizations. They would customize the tool to attack the victim system, like create a malware which exploit the specific weakness of the computer system, craft an email which is persuasive for the user. Third step is delivery. They will send the email to the user, or if they know they can carry out through web attack or USB attack. Fourth stage is exploitation. In this stage, the malware get into the computer system, exploit the weakness to run. In the fifth stage, called installations. So the malware will establish its footprint in the computer system and replicate itself and establish its persistence so that it makes sure it be there. In sixth stage is called command and control. Once the malware is established in the computer system, we contact back to the server of the threat actor. And then the threat actor have control of the malware running on the victim computer system. And the seventh stage is the final state action and objective. Then the threat actor will carry out the actions on the computer system to carry out its objective, either encrypting the computer system of the victim to steal, or ransom or steal sensitive information. And so, since next one, in the next step, I'm going to talk about the most important cyber threat. So the first one is malware. So malware is software written with malicious intent, and it is the most prevalent cyber threat. The common malware includes like virus, which is a malicious code which attaches itself to another normal executable, like Windows, Word, or Acrobat Reader. The second type of malware are worms. So worms has the ability to replicate itself across computer in a system. The spyware are used to steal information from the user, and ransomware and encrypt the whole file system of the victim computer and use it to ask for ransom. So for some statistics, in 2018, Symantec has reported 246 million new malware variants. The top malware file type are Microsoft executable, PDF, and Microsoft Office document. So malware are executable, but they are on own type of different files, like which are not executable.
Quan, could you mute everybody? Someone's typing and you can hear their keyboard clicks. Actually, they're not muted. So could you mute everybody, please? Sorry.
Actually, yeah, I'm not so sure how I could do that.
Is it done?
Let me check.
Or could we ask everybody just to mute themselves, please? Maybe, I think there are two people who haven't actually, Kelly Price and Bunch. Thanks.
Yeah.
Sorry.
Okay. Yeah, okay, I see that. You don't. Yeah, okay, that's done. So the next cyber threat is web-based attack. So web-based attack exploit the vulnerability of web component to steal user-sensitive data or to install malware on the user devices. So one type of web-based attack is click jacking. So it shows the user some persuasive information, but underlying it, if the user click on some button, it will carry out some bad activity. The second one is like a kind of web-based extension. So like you have web extension for Firefox or Chrome, and they can actually also steal information from your computer. So for the Firefox one, extension in the first version has all the control accessing on the file system of the computer. On the right, I have an example of the attacker using session jacking to hijacking to steal information from the visitor and use it for himself. So for example, like it could, when the visitor, the victim is using a banking session and the attacker could steal that session and use it to transfer the money from the user bank account to himself. So for some statistics, according to the Cybersecurity report in 2019, there are at least like 19.8, 20% of computers were targeted by web-based attack. The third type of attack, web application attack. So it is similar to web-based attack. Web-based attack aim at the user, and the web application attack aim at the web application, the web server. And it exploits the vulnerability of the web application to attack the application data and the computer system running the service. The most popular one is the SQL injection, where they write malicious code on the SQL query and use it to steal information from the SQL database server, or carry out delete data. According to the statistics from Akamai from 2017 2019, the amount of attack, the frequency of attack for web application attack has increased more than 4 times, from less than 5 million on average, less than 5 million attack per day on average, to nearly like 30 million attack per day. And another one is phishing. So phishing is an attack which uses social engineering technique to deceive user into disclosing sensitive information or to download malware. The attacker would write an email which impersonate that they are from a legitimate entity, like banking or higher officer in a company, and persuade the user to say click on the link in the email, and then deceiving the user to submit the user credential, or click on the malware and download the malware to his own computer. So there are different types of phishing. That you have spear phishing, where the attacker use personal information from the user to make it more persuasive, and you have whaling, which aim at corporate user. Recently, you have like smishing, which use SMS to attack the user. So sometimes you see like SMS from Bank of Ireland, which try to persuade you to go to some, disclose some information. So phishing is usually used in the first initial stage of the cyber chain to carry out other attacks. It could be used to carry out, spam, botnet, malware, information leakage, or data breach, cyber threat. For statistics from Vericom, 32% of breaches involve phishing activity, and 94% of malware are delivered through email. So the traditional cybersecurity protection is falling because the network bandwidth and the amount of data generated by the user has exploded with the use of social network and Zoom for meeting, and with 5G networks coming into use soon. The computer system have become diverse and more complex, and the attacks have become much more sophisticated. The traditional signature-based approach to detect cyber attack is simple and static. So usually the cyber analyst only look at one type of attack, like Mirai botnet, and derive the signature to recognize it. And obviously, if you look at only one type of attack, the signature will not generalize to future attack. So why machine learning for cybersecurity? This is the second part of my talk. So advantage of machine learning for cybersecurity is that machine learning can automatically form a large amount of data from multiple type of attack in the past and generalize to future attacks. Machine learning can detect imprecise pattern for cyber attacks through churning data, which generalize to new attacks. And it can scan through large amount of data automatically and only report suspicious signal to the cyber analyst. By this, reduce the amount of information that the cyber analyst have to look at. It can combine different attack patterns for best performance. And machine learning model can be updated progressively with new data over time. There are challenges for cybersecurity data, applying machine learning for cybersecurity data. The first thing is cybersecurity data is quite opaque. So it's not like speech data or image data, text data. I can look at it and understand it. So it is difficult to collect label data due to data opaqueness. The data set is highly imbalanced. You mostly have benign data like normal interaction, and you rarely have malicious activity from the cyber threat actor. And the third problem is that different computer systems are different. So the data characteristic depend a lot on the network or computer system topology. So for machine learning technique in cybersecurity, due to the characteristic of cybersecurity data, it has its kind of machine learning tool which could be used in it. So the first one is the most popular one is supervised learning for label data, and we have supervised model including decision trees, supervised machine, and recently deep learning has emerged as the popular tool for supervised learning because of its ability to learn feature automatically through multiple layers of transformation. So this, as in cybersecurity, most of the data are benign and only some of them are malicious. So the second part is the set of tools which are actually specific for machine learning for cybersecurity is anomaly detection. And it includes like unsupervised learning, which try to cluster data in different cluster and hopefully all the benign data will belong to certain set of cluster, and malicious data belong to a small set of cluster. It's still like supervised learning for label data, but there are techniques to customize to the case where different classes have different number of example, or it could be something between called semi-supervised learning. So learning on a small set of labeled data, but also take advantage of available unlabeled data. So next is like I'm talking about a different area in cybersecurity where machine learning has been applied to. So the first area is intrusion detection. Okay, sorry. So intrusion detection system is like the big part of cyber defense. An intrusion detection system is usually placed on a computer system, on a network, or on a computer to detect malicious activity that happens on its network traffic or on the computer. There are different types of intrusion detection. There are network-based intrusion detection system, which observe the network packet, which is passing the computer system to detect malicious activity. And there's a host-based intrusion detection system, which look at the log file of event on the computer, log file application to detect malicious activity. And another type is actually a subset of the host-based intrusion detection system, which is called application-based intrusion detection system, and it's specific for each application. There are like a long tradition for open source intrusion detection system, which have been developed, but all of them are signature based, including Snort and Suricata, the two popular systems. So there are so here are the comparison between host-based intrusion detection system and network-based intrusion detection system. So the host-based intrusion detection system aim at inside intruder, and the network-based aim at outside intruder. For threat response time, the network-based system is fast because it just read through the packet and it can reply, it can act immediately. The host-based intrusion detection system takes a long time because it has to observe the activity trend over time before it can detect, malicious activity. But because the host-based intrusion detection system has much more detailed knowledge about what's happening, it's much better at assessing what the threat actor has damage on the victim system. For machine learning for IDS, they have supervised learning model like support vector machine, deep learning model, convolutional network, long short-term memory. Anomaly detection is applied a lot on intrusion detection system, including autoencoder, deep belief network, or they also use unsupervised approach like clustering. So the challenge of applying machine learning for intrusion detection system is that the data collected is influenced a lot by specific computer system configuration. And the machine learning model may have hard time to distinguish patterns which are specific to the attack and patterns which are specific to a computer system. But yeah, but like so, fortunately, there's one thing here is there are a lot of penetration testing library which are developed for penetration tester to test computer system with simulated attacks, and we actually can use this library to help us to train intrusion detection system, but it's a new area that I think no one has tried yet. So for machine learning in detecting social engineering or phishing detections, you have like phishing email detection. So this is basically like using text classification model to classify whether a piece of text is malicious or not. For phishing URL detection, you can use machine learning model on feature extracted from HTML and feature extracted on the text, of the URL page. You can also use meta information, for example, from an email to see if it's from a suspicious mail server or not. But the challenge this is that most of the phishing email datasets are quite dated. I think the Enron datasets are from 2006, and we don't have any current email dataset. So that's a reference for machine learning in this area. At the end of the slide, want to look at it. So finally, it is machine learning for malware detection, which is our favorite area. I think malware detection is where machine learning could be applied most successfully on it, because all the malware have kind of the behavior of all the malware are mostly constant across different computer systems. So for machine learning for malware detection, that they categorize it based on the feature extraction methods. The first one called static analysis. You extract feature from a software without running it, build a classifier using the extracted feature as input. So there are multiple static feature extraction. Like you can just look at the malware byte as a big byte sequence. You can disassemble it and convert it into assembly code. And by for dynamic analysis, you run the software in an isolated environment. You record its behavior and use its behavior as input for the malware classification model. There are different machine learning approach for malware classification or malware detection, like hidden Markov model. But the most successful one that we have seen so far are supervised model, and deep learning with complicated architecture have been applied on malware detection. So next we talk about our work in malware classification. So we have been working on this area for quite a long time, and we have some publication on it. In this talk, I talk about our work deep learning at the Saloen malware classification for non-domain expert. It's published in a paper in 2018. For this problem, we work on a malware dataset which is created by Microsoft. It's a big dataset with 400 gigabytes of data uncompressed. It has the 9 family of malware, which you can see on the right. It is highly imbalanced. For some malware family, there are like 3,000 malware, and another one might have only like 30 or 40. So our image-based approach for this is we just look at our approach is like using static analysis. We look at a binary and executable just as a byte sequence, and we convert each byte into corresponding to a gray level of percent between 0 and 255. We use image compression technique to compress a byte sequence to a byte sequence of fixed length of 10,000. That's an example. There's some example of the the byte sequence on the right, which we converted to images for easier visualizations. Then we use deep learning model to learn and classify the byte sequence into one of the 9 family of malware. So for this, we use the our deep learning model is CNN by long short-term memory. So the input is a byte sequence with a convolutional layer on top of it to learn local pattern. And then we have a long short-term memory on top of it to learn global pattern from the data, and finally go to the output layer to classify the malware family. So our final model performed quite well. It got 98.2% accuracy in the 5-fold cross validation protocol. It got 98.8% accuracy when training on 9/10 of the dataset and testing on 1/10 of the dataset. Our work is quite popular. It is like one of the top 10 most analyzed paper in the journal. So you want to know, like, if our deep learning on image extraction method actually work in reality. And we are lucky, like we find recently that there's an approach similar to us, which actually is a collaboration between Microsoft and Intel. So they developed a new deep learning approach for malware detection. So in their approach, they similarly convert malware binary into pixel, but then they resize the data into an image. In our case, we just look at it as byte sequence. Both are image-based approach. They apply transfer learning on pre-trained deep neural network. In this case, Inception version 1, and then they evaluate the model on the label data. On a data set of 2 million executable, they obtain very high accuracy, 99.6% recall for malware, and 99% accuracy. So fortunately, so the researcher of this work also applied their model on the Microsoft malware challenge dataset like us. So we compared our model with their model, and we see that their model, Inception version 1, it has like 5 million parameters. Our model has 270,000 parameters about. On performance, we got like 98.13%, and we got like 98.2 or 98.8% depending on how we run it. So our model is like 120 times smaller than their model, and our performance is better. It also means, like, our approach could be applied in reality. So for our current work in malware classification, we aim to build a big malware data set with our collaborator, could be up to 1 million executable. We use meaningful feature extraction, convert each executable to an assembly program. As the feature is more interpretable, we think maybe you can apply something on top of it, like explainable machine learning, and we are going to use more complicated deep learning model to capture different attack patterns. So to conclude, cyber attacks are happening at high frequency and high complexity. Machine learning is an approach to scale up automatic cyber defense, but data annotation is one main obstacle. So we hope that new approach in deep learning and machine learning, like semi-supervised learning, transfer learning, should help to improve machine learning model performance. But of course, the threat actor will also use machine learning to automate their cyber attacks. So in future, it will be a race between machine learning for cyber attack and machine learning for cyber defense. Yeah, thank you for